Hello. How are you guys doing today? Today I'm doing some simple array preparations. Yesterday's practice session was a disaster. I tried 2 questions and none of the 2 solutions worked. So today I'm going a little easier problem sets, and yeah, so I'll be doing this. I'm gonna stream for 30 minutes and then end the challenge here. So I already solved these 2 and I'm gonna solve this problem. So comparison sorting. Okay, so quick sort usually have running time of n into log of n, but is there an algorithm that can sort even faster? In general, this is not possible. Most sorting algorithms are comparison sorts, i.e. they sort a list just by comparing the elements to one another. Comparison sort algorithm cannot beat n into log of n. Worst case, running time, since n of log n represents minimum number of comparisons needed to know where to each place. Nope. Okay, so alternative sorting. Alternative sorting is method the counting sort does not require comparison. Instead, you create an integer array whose index covers the entire range of values in your array sort. Each time a value occurs in the original array, you increment the counter at the index at the end, run through your counting array, and printing the value of non-zero valued index that numbers of times. So for example, we have this array. All the values are ranges from 0 to 3, so create an array of zeros result 0 to 3. I'm confused. Okay. I have no idea what it is. Okay. This sorting method is counting, so does not require comparison. Instead, you create an integer array whose index range covers the entire range of values in your array to sort. For each time a value occurs in original array, you increment the counter at that index and run through your counting array. Okay, so index 0. Okay, and when we hit 0, okay, so example, all the values are in the range 0 to 3. So create an array of 0, result 0. The result of each iteration follow. So when 1 you increment the index. Okay, 1 index. Okay, I think I got this. So this is pretty much simpler than I thought. So for basically what it's asking us to do is it's written here. So we create an array with, say, array of length same as the input array, and then we assign 0 to all, and we loop through AR and increment the index, increment the elements in created array with index of with the current AR index, because we are in the loop, right? So let's do const counting. So counting array equals new okay. Let's do this ar.map. Okay. I equals 0, I is less than arr dot length I plus plus and I plus plus, and I plus plus. Okay, I plus plus. So okay, so of ARR of I. Huh. Let's try this. Okay, did it plus two? Okay. Let's try one more. Okay. Okay, so let me think through. Okay, let's do this instead. Okay, let's do this, right? Let's do this. And map no count of array, then we equals to 1, continue. Okay. Why it's not working? Why it's not working? Why it's not working? We assigned. I say if array is 0, value is constraint value will be less than 0. What is n here? N is greater than 0. Oh, number of elements will be, that doesn't make, oh yeah, value is less than 100, so it is between 0 to 100, and there's no problem with the length of the thing. Okay, let's do something. Value is less than 100, so let's create a new array. Let me look up how. let's do this. Okay. Instead of doing this, new array of length of maybe okay. See if this works. And okay, let's do 100. Boot test case passed. Everything looks good. That is so stupid. So basically we are instead, oh, now I see the problem we were having, because we were initially initializing the array of, for example, if array has like, I don't know, 1 million elements, we are creating a counting array of 1 million indexes, and we are trying to increment them, but only 0 to 100 applies to our calculation. So that's why it was failing for other tests and passing this, because it has just 100 elements and the other has just 100 elements. So we got let's try this mock test and see how we okay. 24 minutes, that will be ample time. I agree. Posting my email, flipping metrics, solve. Okay, flipping. Okay, Sean invented a game involving a 2n into 2n matrix, in where each cell of matrix contains an integer, okay, 2n. So this is always an even numbered matrix. He can reverse any of its rows and columns any number of times. The goal of game is to maximize sum of element in n submatrix located in the upper left quadrant of the matrix. Upper left quadrant of the matrix. No, so first quadrant. Okay, in this case we need to replace 4 versus 1. Reverse row. Okay. And cast it. Holy moly. Okay. So we what I'm thinking, oh no, that doesn't work. Huh. Why challenges are so simple and okay, so what I need to do, okay, so if it's 2n, then we need to think about n divided by 2, right? N divided by 2. So we always get our quadrant. Okay, so this is okay. You can change rows, you can change columns. This sucks. Okay, so I think question for example, if we go through this, okay, we sort each of them. Okay, we go through the loop, sort them here, so in ascending order and descending order. Okay, descending order, that's how. Okay, that works. So loop through the matrix, sort rows and columns in descending order, and then get sum of first quadrant. Okay, that's the gameplay here. So since we don't have much time, I'm gonna start writing code. So I'm gonna do a brute force, which will be 2 running loops, loop inside a loop. So for I is less than matrix the length I plus. Okay, so here the magic starts. Okay. Oh, sorting is a problem. Okay, the first part is not big of a problem. We just do this. A matrix of I equals matrix of I that sort A B is greater than A. Okay, that'll be, so we sorted the rows out, but how are we gonna sort? Okay, now we sorted rows out. Now we're gonna sort the columns. How are we gonna sort the columns? We only care about two of the rows. So what we're gonna do is so since it's doesn't matter, so we can sort it here, right? Can we? Okay, now we need to inverse the row and column. This is okay. So we got all these values here. Now I'm thinking I'm trying to how are we going to reverse it? How are we going to reverse the whole thing? Okay, so let's do this. We're gonna for let I equals 0, we're gonna reverse the whole thing. I is less than how much time left? 12 minutes. Matrix dot length and I plus plus. So we're gonna reverse the whole thing. Okay, so how are we reversing it? Okay. My God. For let j equals 0 is less than matrix dot length j plus plus. Okay, how are we reversing it? So in order to reverse it, okay, const bucket, we put it in a bucket. Okay, bucket. Okay, let's do this. Okay, so what our goal is to say move this up, right? For example, if we want to move that up, matrix of I of j. So initially it's 1. So if you want to reverse it, how would you do it? You equals no, we need to do reverse. Okay, is equals what the okay, so matrix of I and matrix dot length minus 1 minus, okay, j, right? Is it j? Okay, we don't need this. Okay, I of I equals minus I, right? And matrix of this thing equals, so this thing equals matrix, this thing equals this stuff, so, and this thing equals, and this thing equals, this thing equals I equals, we put I here, this one here, and this one here, this one here. We need to put this one here, right? So that will be matrix of this time, oh okay, this time matrix of so row is 0, so that will be okay. If we reverse like that and it get concentrated down there, if we reverse top right, works. Okay, so then this thing is what is 0, or the column is 0, right? The column now. The row is 0. Okay, row is I. Okay, let's do this and run code again. Okay, let's do this, run code again. So 12. What? So didn't work? Let's do a sort. Okay. Huh. How is this possible? I'm confused. Okay, so this one, how is... Okay, const sorted matrix equals... Okay, I'm gonna run out of time, but Okay. Thank you so much for hanging out with me and test timed out. That was also a disaster, but we managed to solve this problem. And yeah, I need to do a lot more than I'm doing right now. So yeah.